converting a 1.8 meter fixed dish to azimuth elevation control. So I started getting interested in Earth, Moon, Earth radio signals, where you transmit from the Earth, bounce the signal off the Moon, and listen to the signal come back to the Earth. My father, K1PTF, let me know about the Graves radar system, which is a radar in Europe that is typically used to track objects around the Earth, but it's strong enough that it's actually really strong, and it can bounce signals off the Moon, and you can pick them up with very relatively simple stations. So I was using my satellite station for 2 meters and was easily able to pick up Graves radar signals. That started leading me down another path when I bumped into K1GT's website and talked about using off-the-shelf satellite dish, small satellite dish antennas and low noise block converters at 10 gigahertz to listen to amateur 10 gig signals being bounced off the Moon. I was fortunate and found a small 1 meter dish available for free. Just had to come and pick it up off the scrap heap. And I set that up with an LNB that I picked up off of Amazon. And during one of the contests, one of the Earth, Moon, Earth contests, set up in my backyard and just kind of manually pointed it and used an SDR to listen to signals. And sure enough, I could pick up signals being bounced off the Moon. So I could pick up some Morse code, picked up some digital modulation, and that kind of got me excited. As I was poking around YouTube, I found Skip McCulley's website, his videos, and Skip has some pretty amazing stuff. He's got huge dishes. He's an amazing builder, but he had a little bit smaller dish than he has his huge dish on. You can see it on the left here, and then a slightly smaller dish, which was he was going to use for 10 gigahertz. Well, I happened to stumble upon an ad on Facebook Marketplace for a dish about the same size as Skip's, and I had to do a little bit of traveling to go get it. It was about 3 hours away from my house, so I checked to see if it was available, gave a rough offer sight unseen, and they took the offer, and so I said, okay, well, I'll come up and I'll rent a pickup truck and go get it. So I drove up to Maine and found the dish. It was kind of in pieces. There had been a roof mount set up for it. By the time I got there, this roof mount was all taken apart, mostly. And later I learned that some of the pieces had kind of been chopped in order for them to transport on the trailer. But that's okay. You make things work. The dish was installed on top of a warehouse for a supermarket. And this was a construction company that did work for the supermarket. And they didn't need a dish on the roof anymore, so the construction company grabbed it. So I got the parts home and kind of sorted them out. And going off the pictures I saw on Facebook, I figured out what the dish mount, at least the roof mount, should roughly look like. And you can see how there was sort of the elevation and azimuth fixed mounts there on the back of the dish. So I disassembled that. I knew that I'd be putting in a rotator of some sort, and I wanted to see where I'd be starting from. And here's the bracket for the back of the dish. These are super strong structures. They're meant to sit on top of a roof with a lot of wind. So I wasn't going to have any problems dealing with these guys. So I went hunting for what I should use for rotators, and I came across W2HRO's website. He sells Sublunar Systems, and he sells some nice slew drives. And these are originally marketed for holding large solar panel arrays. They're super slow, so not so great for fast LEO satellite tracking, but they're super strong, and they are good for pointing at something like the moon or the sun or anything else that's moving slow. Sublunar has a pole mount that looks like this. And comparing it to what I had, I'm like, wow, I could probably come up with a mounting plate system similar to that and put it on top of the mount that I got with the dish. So I needed to figure out some way to attach the back bracket to the rotators, to the slew drives. And I came up kind of with a rough idea of what it would look like. Kind of convinced myself just with the rough drawings that I'd be able to make something happen. So I went ahead and purchased the slew drives and started playing with those and taking measurements and put them into Fusion 360 and started working on brackets to see what kind of setup I could do. I went with this about the same thickness. It's like 1/2 inch thick steel there. Same thickness because I'm not a mechanical engineer. I'm more electrical, and I knew that the original plates were all about 1/2 inch steel. So I'm like, yep, I'll go with that. That sounds like it's pretty safe. Made up some foam board models to test out the fit and function. Nothing better than cutting out foam board with X-Acto knife. Attached it to the slew drive just to see kind of, did it actually match my CAD model? What are the things that I forget? And I ended up going ahead and ordering a bunch of cut parts from Send Cut Send. Great service. These are all steel parts with a zinc coating. The rectangular parts are aluminum. They are the shims, and I ordered a bunch of different size shims because I wasn't sure of tolerances on the shims, and I just really wasn't exactly sure what the gaps were going to be between the existing frame and then these brackets that were going to hold it. I also needed a couple extra spacers, and I belong to a local makerspace that has a water jet cutter. So cutting out 1/4 inch aluminum spacers is no problem with the water jet. It does a really nice job. So there's an example of the plate with a couple of the spacers. And here's what the mounting post with its plate looks like. So now I can bolt it down and I can adjust a little bit for tilt, and I can still get the bolts on it on the underside for the slew drive. Just a close-up shot of that. There are the bolts on the underside for the slew drive. You can see the spacers that I have in there towards the bottom. And there it is. Now, one thing as I'm kind of swinging this around, powering it up on my workbench, it's starting to get pretty heavy. I measured it. This assembly right here is probably in the order of 70 to 80 pounds as is. And now I'm starting to think that I'm getting a little bit beyond what I may be able to muscle around on my own. But it was working well. The slew drives are working. All the holes lined up, which was great. That's always a challenge for a non-mechanical engineer. There's an example of the shims in place. And I was able to get it up on top of that pole. That was a little bit of a challenge, but got it up there. You can see relative to my my satellite antenna system. So I took the rear bracket, laid it on top of the mount, and found the right size shims and bolted it all in place. Kind of see that there. And there are some shims. I have lots of extra shims. I haven't figured out what to do with all my extra shims yet, but it was nice to have at least a set that worked. And it moved around no problem. So the next problem was going to be, how do I get this dish up onto the bracket? And taking inspiration from Skip, now Skip has a Jeep outfitted with essentially a crane. It's a winch on a long pole with a long pole, and he does some amazing things with that setup. I don't have a Jeep or a crane, but I did have some really, really strong slew drive motors. So I'm thinking, I wonder if the slew drives are strong enough just to lift this thing up on its own. So I strapped it all in vertically, and then I cantilevered and ran it and was able to, without any effort, just lift the dish up off the ground this way. The slew drives are super strong, and compared to the weight of the dish and the brackets, I mean, they're just no problem. Got it horizontal, and once it was horizontal, then I could just slide it around to get it to the bolting points. So here it is sliding into place. Just put in the bolts, tighten them down, align it on the bottom. Boom. Awesome bird bath. And I tested it a bit, just moving the slew drives around, and they no problem moves that dish like it's not even connected. So the next thing was to try to figure out the focal point. So one of the things I did learn is you can see the feed point, the feed bracket at the bottom. That was one of the pieces that got cut. Someone was pretty handy with a Sawzall and cut that off. So I didn't have a good idea of where the feed should be. So I was using the string method. You put a string horizontal, vertical, get some measurements, and then you run some calculators, and you can get your distance from top, distance from bottom, and get a focal point. So I did that and came up with a way to kind of bracket things together and put the LNB out there. You can see here's the back of my setup. I wasn't getting good results though. And I'll come back to that. Right inside that box. So for controlling the slew drives, the circuit board you see there comes with the slew drive. That's from Sublunar, but there's a small box on top of that. And that's a RoboClaw motor drive, and it's meant for robots. It's a two channel, meant for robots, but it can do it'll do PWM output, and it has encoder inputs, and it does PID control loops. You can feed it. You can interface to it over USB. You can feed it positions. You can read out encoder values. It's pretty nice, and it's not that expensive. When I say not that expensive, it's in the $100-ish range compared to if you bought somebody else's system that might be 8 times that. So when I was having problems I was trying to tune up on sun noise. I was trying to point it at the sun and measure the difference the signal was from cold sky to sun, and things just weren't working. So I'm like, all right, you know what? I'm going to go remeasure all this stuff. Double checked some measurements and came up with a different mount with let me do a little more adjusting. Probably was a little bit more careful, and here's my setup. I've got my laptop that can use to point at the sun. Also, it connects up to I have an Air Spy that I was using to receive the signal from the LNB. And there we go. I could actually get some sun noise. I was seeing 8, 9, 10 dB of sun noise-ish without, this was before really tuning it up and carefully calibrating it. But I was at least starting to see sun noise. I'm like, okay, things are starting to work. I needed to put limit switches on because these slew drives were probably powerful enough to tear the whole thing apart if you jammed it up. So I got some outdoor rated switches. They're industrial switches off of Amazon, and figured out some points to put them for the elevation, and also you can see me here for the elevation, and then also for the azimuth. Yep, there we go. There we go. There's another azimuth one with the big spring piece hanging off it. And that's where I'm at so far. So it's definitely been a journey, and it wasn't one of those like, oh, I'm just going to design this and build it. It's definitely been acquire something, work with it, design something for it, test it out. A few things had to be done over and over again, but we get there. I couldn't possibly analyze the whole thing and come up with a perfect solution and then just do it. It was really better to do a piece and keep going. Modeling things, 3D modeling, 3D CAD is really good. Where I did run into problems are in areas where I neglected to model something, where like I didn't model the nipples for the grease ports, and I got lucky. I didn't end up tearing them off with a piece of the antenna, but that was really, really close. And as far as the finding the focal point, yeah, I probably rushed through the first time and made some assumptions, and you really need to take your time in certain places where it counts. And I definitely have more work to do, but it's promising. All right, thanks for watching.